Good morning, everyone. Today we will see one more experiment on external interrupt switches to toggle the LEDs. So one of the experiment you have seen is whenever you have pressed, that is the first example which we did in the lab, when we press a switch, it was going to on the LEDs, okay, along with relay and buzzer. Okay, that's what the program we have already seen. And in this program, the same two switches we use like an interrupt, okay, to learn how the interrupt works. So the same two switches we take it like an interrupt. So whenever there is an interrupt, we have to toggle the LEDs. So if it was 0, we have to make it 1. If it is 1, we have to make it 0 whenever the switch is pressed. So here the switches are acting like interrupts. Normally they may work like a GPIO, that is input output pins. So here switches are nothing but input pins, but sometimes here in the program we are taking like an interrupt. So whenever we press the switch, it means that there is an interrupt to the processor, and we'll see what the processor does. Okay, and here in this, what in the program, we are going to toggle the LEDs. So as we know, each of the pins of ARM Cortex M3 processor has multiple functions. So there are 4 functions for each pin. So similarly here there are 4 external interrupts provided for ARM Cortex M3 processor. Okay, so externally we can apply 4 interrupts at a time. Fine. So where are those external pins defined? So they are on the port pin of 2.10, 2.11, 2.12 and 2.13. So we have already seen 2.11 and 12 are the switches, 2 external switches. Apart from that, 2.10 and 2.13 are also defined to be an external switches. Okay, so the first functionality is the normal GPIO. Second functionality is they work like a external interrupt, and third functionality is different, and fourth functionality is also different. So these are the pins wherein the external interrupts are connected. Okay, next, this is the diagram. This is the LPC 1768 board where we have 4 external interrupts. Usually the program will be executing in the processor. Whenever there is an interrupt on these 4 lines, it stops the execution of normal application, goes to the ISR, which is interrupt service routine, and comes back again to the normal application. So for this external interrupts, again there are number of registers associated with it. So let us see what are those registers which comes under this external interrupts are pin select register. Why do we need this pin select register? Because to select the functionality of those pins, that is 2.10, 11 and 12, 2.10, 11, 12 and 13, to make these functionality of these pins as the external interrupts, we have to configure the pin select register. Okay, and let us see what pin select register we are using at the end. So one we need is the pin select register. Another register is called EXTINT, so external interrupt flag register. So this register is nothing but it will tell you whether there is an external interrupt. Now suppose, imagine that there is an external interrupt on this INT0, then a corresponding bit in this external int register will be high. So it is saying that there is an interrupt on that particular pin. So it will give you just a status of that particular interrupt pin. Next is the mode. Mode will tell you, external interrupt mode will tell you what kind of interrupt is applied to the LPC 1768 board, that is whether it has to be a level triggered or edge triggered. So I hope you know what is level triggered and edge triggered. Level triggered is nothing but when you have a on pulse and off pulse, entire on pulse will be at the level triggered, and edge triggered means whenever the signal is going from positive to negative or negative to positive. So edge of the pulses are called edge triggered. So whether the external interrupts have to be worked on mode, that is level mode or edge triggered mode, that we have to decide here in this register. Next is the polarity. Many times we have seen some components are active low, active high. Okay, and depending on the mode what you have selected earlier, whether it is level or edge triggered, we can change the polarity. So suppose you have selected edge triggered. So there are 2 edges, one is positive edge triggered, negative edge triggered. So that you have to decide. Okay, but when you are going for level, that is what level you can use, active low and active high. So that is falling and rising edge, active low or active active high. So this is how you have to select the polarity. So these are the registers configuration. First 4 bits are for the interrupts, since there are only 4 interrupts, INT 0 to INT 3. Rest all from 4 to 31 bits are reserved. Similarly, in the mode, first 4 bits are for the modes of the interrupts, and then 4 to 31 are the reserved. Similarly, for the polarity, 0, 1, 2, 3 and 4 to 31 are all reserved. So this is about the registers. Now let us see how to configure these interrupts. First thing is, we have to configure the pins of the external interrupts in the pin select register. As I said, second function of each pins in 2.10, 11, 12 and 13 are the external interrupts. So we have to configure that. So that is the first step you have to perform. So configure the pins as the external interrupts in the pin select register. Next thing is, if at all are there any pending interrupts which is not cleared, so what you can do is, we have to clear those pending interrupts in the external interrupt register, okay, flag register. Next we have to configure the external interrupt mode and the polar register as maybe level or edge triggered, or can be active low or active high, falling or rising edge. Next we have to do is first one, select the mode, second one is select the polarity, and then last is finally enable the interrupt by calling one function called NVIC enable IRQ. This is the function for nested vector interrupt controller, and with the IRQ number. So this is the function which does everything. This NVIC enable IRQ is the function written for NVIC. So whenever you say IRQ 0, IRQ 1, IRQ 2, IRQ 3, it is going to entertain whatever is written for that particular interrupt. So but we have to write the ISR for this, okay. So let us see how it is executed. So first thing is #include lpc17xs.h. so this is the first library we have to call, and we have to include. Then there are many number of variables defined here. So let us see what are these variables. First one is pin select enable int 1. So what is this doing? So this is nothing but you have to configure the pin select register as interrupt 1 and interrupt 2. We are not using 0 and 3, we are using 1 and 2. So where is this 1 and 2 connected? It is connected to the 1 and 2 are connected to the 2.11 and 2.12. What are these 2.11 and 2.12? They are nothing but the switches, okay, the switches in your LPC1768 board. So we are going to configure 2.11 and 2.12 as external interrupts, okay. Next is the LEDs. Since we have to toggle the LEDs, so we are using only 25th and 26th LED. So we have that is 19 to 26, okay, pins of port 1 are connected to the LEDs, okay. So we have to make them on and off, or we can toggle them whenever the switch is pressed. So we are using only one switch, one LED, that is 25th and 26th for each interrupt. Next is we have to enable the interrupts in the flag register. So external interrupt 1 and external interrupt 2. So 0 is not used, 3 is not used. So that's why we have 1 and 2 here. Similarly, for selecting the mode, there is one variable 1 and 2. And for selecting the polarity, there is another variable, two variables, polar 1 and polar 2, for defined to be 1 and 2. So everywhere it is 1 and 2 because we are going to work with external interrupt 1 and 2. Not 0 and 3. Next is there are two functions return to handle the interrupts. So these are the two functions which handle the interrupts, and this is how it is standard way of defining it. So how is it defined? Void interrupt 1, external interrupt 1 and external interrupt 2, okay, IRQ handler void. This is the fixed format, okay. This is the ISR written for that particular interrupt. So interrupt, external interrupt 1, IRQ handler void, external interrupt 2, IRQ handler void. So what is written inside this? So LPC underscore SC, okay, this is another API where these all are defined. Okay, so LPC underscore SC external interrupt. So this is the register, first register, external interrupt register, one shifted so many times. So what is that meaning? So when you shift one into that particular position, it means that it is entertained. Okay, it is entertain means it is going to clear the interrupt flag. Clear the interrupt flag means it is taken by the handler to process it. That is the meaning. So 1 is shifted so many times into external interrupt register. So we are making the flag register of interrupt 1 as 1. Next is LPC underscore GPIO 1. It is for the LED since it is connected to the port 1. FIO pin is the register which is used to read the LEDs, and then this sign, okay, this sign is called not equal to 1 shifted LED one time. So if it was earlier 1, now it will become 0. If it was 0, it will become 1. So that is the meaning of this. So it is going to toggle the LED every time whenever the interrupt 1 is generated. The same thing is written for the second handler also. LPC underscore SC external interrupt. Okay, external interrupt 1 shifted, now external interrupt 2. It means what? We are going to handle the second interrupt. So similarly here the LPC underscore GPI on FIO pin, but now it is LED 2 since we are working with 26th pin, 26th LED. P126. So where this has to be toggled every time whenever the interrupt 2 is pressed. So now we will go to the main program. Number of configurations you have to do in the main program is, first thing is we have to clear all the pending interrupts. So what we do here is 1 shifted to ENT 1 times or 1 shifted to ENT 2 times in the external interrupt flag register. So if you send 1 on those particular bits, whatever was the pending request, okay, earlier, they will be taken by the processor. So it will clear all the pending request. Next is pin select 4 register. We have to for select the functionality of the external interrupt. So 1 shifted pin select ENT 1 times or 1 shifted pin select ENT 2 times. So this will configure 2.11 and 2.12 as external interrupt 1 and external interrupt 2. Next is for selecting the mode. So here for selecting the mode we are going with edge triggered. So if it is 0, it is level triggered. If it is 1, we are going with edge triggered. So here in the program we are going for the edge triggered. So whenever 1 is shifted to the mode 1 times and or 1 shifted mode 2 times. So both external interrupt 1 and 2 are kept to be edge triggered. Next let us go for the polarity. So for polarity we are going for falling edge. Okay, so we are not going for rising edge. 0 means rising edge, 1 means falling edge. So why we are going for falling edge? If you remember 2.11 and 2.12, okay, when you press a switch, it low will be sent. Okay, when it is open, it will be high. I had told this many a times whenever we have come across this switches, right? So if you press a switch, a low value will go. If it was open, it was high, so it is active low. So that's why we are going for falling edge triggered here. So when it goes from high to low, it means that there is a switch pressed. Okay, so now FIO direction of the LEDs also have to be set since LEDs are working like output. So 1 shifted LED 1 times or 1 shifted LED 2 times. So 25th and 26th pins of GPIO 1, that is port 1, are made as output pins. Next we are sending 0 on that. FIO pin is equal to 0. So both the LEDs are cleared initially, nor they are made off. Next we call is two functions. That is what I said. This is the this is the fixed function we have to call NVIC. That is nested vector interrupt controller enable. Okay, IRQ. Okay, what IRQ? Which we have to enable? So I enable interrupt 1 IRQN and enable interrupt 2 IRQN. So this will go to these two functions and executes that. So these two functions are written for the handler handling these two interrupts. So this is the way we call the interrupts. Okay, that is NVIC enable IRQ and which interrupts we are calling. So we are calling interrupt 1 and interrupt 2. Okay, so and these will enable the INT1 and INT2 interrupts, and whenever we enabling it, so we have to go to that particular ISR and execute that and come back to the main program. Okay, so next is here we have written while 1 and do nothing. It means that this program will be executed continuously. So these we are not putting all these instruction in while 1. Okay, so these are the few instructions which are put in before while one, because these are like a settings. Okay, for interrupts, these it's not polling, right? Interrupts are nothing but whenever it is pressed it will take it, but this has to be done continuously. So the while is written outside the functions of NVIC and NVIC IRQ1 and IRQ2. Okay, so I hope you understood this. This is for the external interrupt. Fine. Let go through again. If you have any doubts, you can ask me in the group. Okay, and if you clarify your doubts, execute this program in the Keel software and check for the simulation result. Okay, thank you.